Hey, fellow mathers, we've got exciting news for you.
Yep, the registration for the free Math is Figureoutable Challenge is now open.
Get ready for a fast-paced learning experience where you will, 1, learn all about problem strings at all grade levels, 2, why problem strings matter and can help you in ways you never thought possible, and 3, engage in super cool mathing.
We'll have special guests, free downloads, prizes, and most importantly, high energy engaging sessions.
Join us for 3 one-hour sessions May 14th through the 16th at 7 p.m. Central Time. And that's me. I keep going. Register at mathisforgettable.com/challenge for a fantastic learning experience. That's mathisforgettable.com/challenge. It's as fun as it is listening to us on the podcast. Now on to the episode. Hey, fellow mathers. Welcome to the podcast where math is figure-outable. I'm Pam Harris, a former mimicker turned mather.
And I'm Kim Montague, a reasoner who now knows how to share her thinking with others. At Math is Figureoutable, we are on a mission.
Let's be on a mission together.
We're on a mission together to improve math teaching.
Hey, how come you say a reasoner who now knows how to share her thinking, not her reasoning with others? Is that because we don't want to...
Probably because I don't want to say reasoning twice.
Okay, all right.
Yeah.
Hey, y'all, we know that algorithms are amazing human achievements, but let's be clear, they're terrible teaching tools because mimicking step-by-step procedures actually traps students into using a digit-oriented approach to everything and using less sophisticated reasoning than the problems are intended to develop, and they then question their math identity, and we get this pandemic of, I'm not a math person, false stuff.
And in this podcast, we help you teach mathing, building relationships with your students, and grappling with mathematical relationships.
And we invite you to join us to make math more figure-outable. You don't like it when I go off script so much, huh?
No, I think it's fine.
No, okay.
It can be boring to listen to the same thing to the start of an episode.
I mean, it's boring for me to say the same thing every time.
Yeah. All
right. We'll get to episode number something cool and we'll change the intro again, but not today.
Yeah. 2:55 is not the time.
Nope.
Okay. So yay. If you've been listening the last 2 episodes, then you know we have chosen a problem string and we've unpacked all the things to think about when you're choosing. Mm-hmm. And then we unpacked all the things that you can think about when you're planning the string. So you have a string, you've planned the string, and you have facilitated the string. And so now maybe you're wondering and you're thinking about what you've learned from your students. You still have some wonders. So what happens after a problem string?
Yeah.
Yeah. And before we get started into that, let's have a string in the beginning here so that we have something to talk about and we can do some math together.
All right. So let's do a little math and then we can talk about that as we talk about if you've done this one, what are you thinking after that? All right. So Kim, I am thinking about the fact that I was in Canada recently and in Canada, they have these M&M-like candies.
They're not M&Ms.
They're not, but they're like, and they're called Smarties.
Yeah.
So people in the States, if you think of a Smartie, you think of that chalky kind of disgusting sweet. I don't like Smarties in the United States. They don't make me happy.
Can I tell you?
It's like sugar. Yeah.
My kid is in this dual credit history class right now.
Okay.
And apparently right before a test, they have this, I don't know, Quizzle, Wazoo, whatever they do, whatever this thing is.
Like an electronic quiz thing? Is that what you're
talking
about? Okay.
Yes, I guess.
Okay. All right.
And he comes home and they've done 2 or 3 of them. And he, is like the king apparently of this, whatever this thing is. And he comes home and he dumps a pocket of his backpack out and just like lands Smarties all over the kitchen counter.
Yeah, that's what he won.
Piles and piles and piles of them. And I'm like, hey, can you share with your friends? We don't want those.
Okay, so are you talking American Smarties then?
Yes,
like
US
the chalky
Smarties?
ones.
The chalky ones,
yeah.
I don't actually hate them.
Oh, do you like them?
I wouldn't say.
See, that would make sense because I don't like them, so that would make sense that you would. Which is why we get along so well when we travel together,
it's
right?
Nostalgia. I had them as a kid, yeah.
Oh, yeah, no.
Yeah.
Not worth, no, yeah. Okay, anyway. When I was in Canada, a dear friend Kathy gave me several boxes of Smarties. Thanks, Kathy. And not watching my waistline there. So these are like M&M like kind of candies. And the one particular box, when I counted the Smarties, because I sort Smart. Do you sort, like, if you're eating M&Ms or Skittles or whatever, do you sort them by color?
You know, I don't really eat candy all that much anymore, but I think so.
Okay.
I
All
did
right.
Skittles because they have different flavor. M&Ms I don't care about because they taste the same.
So you don't want to be surprised. You don't want to just grab a Skittle and then pop it in your mouth.
Well,
and be
I have
surprised.
favorite flavors,
See,
so that's
okay,
when it matters.
There you go. Unlike like M&Ms and Smarties, they taste the same. So maybe it's not. Whatever. I still sort them. I don't know why. My daughter and I sort together. They used to talk about sorting chips. Anyway, here we go. So when I counted them, as I was sorting them, there were 26 Smarties in the box. So if there's 26 Smarties in the box, how many Smarties are in 10 boxes?
260.
Okay, so I've just drawn a quick table, and I've put box on the left and Smarties on the right, 1 box to 26 Smarties, and then underneath that I wrote 10, and then you said it was 260. So now I have 1 to 26 and 10 to 260, yeah? Because if you have 10 times the number of boxes, you have 10 times the number of Smarties. Cool. What about 5 boxes? If I had 5 boxes of Smarties, how many Smarties?
130.
Because
5 is half of 10, so 260 halved is 130.
So if you have half the number of boxes, then you would have half the number of Smarties, and that you said that was 130. Cool. What if we had 15 boxes of Smarties that had 26 Smarties in them each?
Then you would have 10 boxes and 5 boxes.
Okay.
And so 260 Smarties plus 130 Smarties is 390 Smarties.
All right. So I've written in the table 15 and 390, and I've drawn a little bracket from the 10 and the 5. And I'm like, 10 plus that 5 boxes is 15, and then a little bracket, 260 plus 130 Smarties is 390 Smarties. Okay, cool. What if we wanted 16 boxes of Smarties?
Okay. So it's going to be 26 more than the 15 boxes, which was 390. And that's going to be 416 Smarties.
Because you added the 15 in the 1 box. So again, I might draw brackets over there between the 1 and the 15 and arrow down to the 16, then the corresponding Smarties, draw a bracket, and then, 416. Cool. But what if I really like chocolate, which I do? It's terrible. What if I wanted to have 50?
Can I?
50? Yes.
This whole time?
Yeah.
I know we had this conversation about the Smarties.
Oh, okay.
But you kind of threw me when you said chocolate because I've been picturing Smarties, chalky Smarties. Okay. I was like,
chocolate,
wait,
chalky,
new context? Okay, so how many did you say?
50. They're colorful.
Yeah.
I think they're actually bigger than M&Ms.
Yeah.
Yeah. Okay.
Then you would have 1,000.
You're not excited because you're not a chocolate fiend. You don't. You can turn chocolate away.
Yeah.
Yeah. Okay.
1,300.
Because
5 boxes was 130. So 10 times as many boxes give me 10 times as many Smarties.
And you had 130, and 10 times 130 is 1,300.
Correct.
Okay, cool. But that's too many Smarties, too much chocolate. So only 49 boxes.
Then I have 1,274 Smarties.
I have to ask, did you just play I Have You Need in your head?
I did indeed.
So it's like, if you're going to take, yeah.
So I had 1,300.
Thank you.
And I
1,300 Smarties.
And I wanted to get rid of 26 Smarties because I want to get rid of 1 box.
Okay.
And so then I was looking at the 26 and the 1,300, and I said, what amount is going to give me the partner to one of the hundreds? So I know it's 1,200 and the partner to 26 to make that last 100.
Nice. And so if I have 26, you need 74.
Yep.
Nice. Cool. So you had, for 49 boxes, you got 1,274 Smarties, whether they're chocolate or chalky, either one. Brilliant. Okay. So there's a problem string that we can kind of refer back to where we kind of ended with the problem 49 times 26. But to be clear, the goal of the problem string wasn't to solve the last problem. The goal of the problem string is to develop what, 5 is half of 10 in this case,
Mm-hmm.
the strategy, and get lots of answers and build relationships in kids' heads with like times 10 and 5 is half of 10 and 50 is half of 100, or in this case, 50 is 10 times 5.
Mm-hmm.
So all those and some nice subtraction relationships. The goal of the problem string is to develop all those relationships, not just to get one answer. All right, so now we have a string to talk about.
Yeah.
If we do that string in class, what are some things you're thinking about now?
So if I'm working with a group of students, and I facilitate a string like this, as soon as that's over, I'm kind of taking in all the information about the students and what do I know about each of the students in the class that I heard from. It's very unlikely that I heard from every one of the students in class or saw every single one of the students record something on paper. So I have to make a choice. How much evidence do I have from the majority of the class? If I don't have enough evidence from the majority of the class, I have to think about, do I want to do another problem string like this so I can get around to more students? So things to think about. Would I want to do another problem string like this, same size numbers, but do it on a different model? So on this one, you mentioned that you wrote it on a ratio table. So do I also want to build 5 is half of 10 with about the same size of numbers, but maybe do it on an array, a ratio, an area model?
Yeah.
Do I want to change the size of numbers or the type of numbers? Would I maybe want to continue to work with a ratio table with 5 is half of 10, but maybe increase the size of the numbers so that I can get more into deeper content? If I'm a 4th grade teacher and I have students and I start with like a two digit number, when do I want to switch to maybe a 3-digit number? Do I have enough evidence that the majority of my kids were hanging with this strategy as I've done this string that I can bump up a little bit?
Yeah, and let me get if we could be a little specific with just this particular string. I used 1 to 26. So one of the things you said is, do I want to keep about the same numbers? So if I was going to do that, I would probably choose another even number because that's going to impact how things play a little bit. I might choose, but if I wanted to up the numbers, then I might choose an odd number or I might a higher number because that's going to impact when I start adding the 10 boxes, 5 boxes together. It also impact the subtraction when I'm going from the 50 box to the 40 box. Go ahead.
Well, so you might change the number of Smarties, but you might keep the relationships the same: 1, 10, 5, 15, 16, 50, 49.
Yeah, exactly.
You might also choose to do another. So we call these an echo string, where you're keeping kind of the same relationships, the same size of numbers. You might change it to this, like a similar number of Smarties, like 24, change a few of the relationships that are playing out. So not 1, 10, 5, 15, 16. You might choose different, a little bit over and unders of the 5 is half of 10.
Yeah, so I might do 150. I might do 100 boxes and then 50 boxes and then 150 boxes. That would be another, and then 149 boxes or 151 boxes. That would be a way to sort of up the numbers. But then if I have maybe 5th grade, 6th grade and up students, I might find a half of a box and then find 15 and a half boxes or 49 and a half boxes. So other ways of kind of making, well, in fact, 1.5 boxes to get to the 150 boxes. Yeah. So other ways of making the numbers so more, not just bigger, but more complex, but still getting at the same strategy as 5 is half of 10. So kind of asking myself, what are the numbers that my students are expected to mess with? And upping the ante in one of those ways, either the number of Smarties in the box or changing the numbers of boxes that we're finding. Yeah. Nice.
So we tend to call those echo strings or next step strings. So when I've done the problem string, I've gotten information and I have to decide, do I do an echo string? My kids need some more experience.
It's like it's a very alike string where not much has changed, right?
You call them sometimes sister strings. Yeah. So they're within the same range of numbers, same model, not a lot changed.
String.
Or am I ready to bump it up a little bit to do a next step? And we are big fans of saying that you don't want to change too much at once. So you might switch models, but keep the numbers and the strategy the same.
Yep.
You might switch size of numbers, but keep the rest the same. You might switch type of numbers, but keep the rest the same. You might say, wow, my kids really owned that strategy, and I could see them pretty quickly using this strategy. So now I'm ready to introduce the next kind of strategy. Maybe you've done a few of this particular 5 is half a 10 string on a ratio table. You've done the gamut of numbers. You feel really good and confident that your kids are owning it. You see it in the rest of their work, and now you're ready to switch to a different strategy.
Yeah, and let me maybe mention one other kind of next step that you might consider upping the ante. For this particular string is you could begin to ask, give kids the number of Smarties and ask for the number of boxes.
Mm-hmm.
So that's like division. Like the problems that you and I just did were kind of multiplication problems. But if I switch that out and say, hey, what if I've got 1,274 Smarties? How many boxes? Now the kids have to kind of do division problems, and I would want to help them realize they're doing division. So that's another way of kind of upping the ante. Another way of upping the ante, depending on your grade level, if I'm a middle school teacher, I definitely want to get into decimals at some point, but then I also want to graph these as ordered pairs. So the number of boxes are going to be X, and the number of Smarties is going to be Y. And, is there any pattern to that graph? And then once we've graphed that pattern, we're going to see it's pretty linear. Why is it linear? Because for every one box, we have the same number of Smarties. One other box over. If you could see my hands, I'm like going over a box and up the number of Smarties, and over a box and up the number of Smarties. It's a constant rate of change. If you have 0 boxes, you have 0 Smarties. So it's also a proportional relationship. Since it is, we could pretty early at grade, often it's a 7th grade, we could write the equation for that proportional relationship. Around 8th, 9th grade, we could shift that and actually talk about transformations. So, a way of upping the ante in the string itself for the students I have is starting with content that kind of helps them feel the relationships, and then going to the content that I teach in my grade level, or like we said, upping the ante with the numbers, and then maybe going further. Maybe the first time you only do the numbers, and the second time you graph it and write the equation, and the third time you transform the equations. So things to think about, like the next kind of thing that you might do.
You also might make different choices for different students in your class. So you might do a problem string on Monday, and then another same strategy on Tuesday. You might be ready to do a next step or up the ante string on Thursday or Friday. But you might say, man, I've got a group of kids in my class who I feel like could really use one more experience before we up the ante. So you might pull a small group and say, okay, let's do one more echo or like a half step before you make an opportunity, give an opportunity for the whole class to do a bigger next step. Just a little bit of intervention there.
So you can make a different choice for a small group.
Yep.
Yeah, nice.
You also might consider that once a strategy has been developed, then you could take that strategy to a game or some sort of other practice where they are applying the strategy outside of a problem string, and you're seeing what happens there before you make a decision about what to do with the next group of strings that you're going to do.
Yeah, nice.
Yeah.
Nice, yeah.
You also might have to think about, when is it time to anchor? And I'm going to suggest that it's not appropriate to anchor the very first time, but you have to consider, when do I want to anchor?
Yeah, so if you've done a problem string, if like the one that we just did, it's most of the time, if not all the time, you wouldn't want to say, great, you guys all own the 5 is half a 10 strategy. We're done with that. Let's put it on a poster and never revisit it. For all the reasons we just said, you're going to want to up the numbers, make the numbers more complex. You're going to want to change the number of Smarties versus changing the number of boxes, get further away from the nice numbers, and change the model. Like there's more to do to really cinch that strategy. But I'll also mention, because I'm high school, remember, that there are times that I might be trying to develop something in my high school students where we really don't have an opportunity to go back to that, but I'm going to raise it here quickly as I do a problem string into content that I teach. The kids have now at least had some exposure to 5 is half a 10, but really I'm talking about writing the equation to that proportional relation or like transforming it. So
what would you anchor in that situation?
Like in the situation where
you've done it once and you're
it's a good question. I don't know that I would anchor the 5 is half a 10 problem string. I might mention it. I might go, hey, that's a really helpful sorry, problem string, I said meant strategy.
Mhm.
I might say that's a really helpful strategy when you guys are multiplying, but hey, let's anchor this idea of how do I know if it's going to be a proportional relation? Or,
Mhm.
hey, let's anchor the idea of how do I write the equation for that proportional relation? Or, hey, let's anchor the idea of why could we transform this function this way this time
Yeah.
if my goal that day is transformations. But let me be clear, if my goal that day is transformations, I did not just do enough to solidify transformations. So I'm not anchoring that on that first day.
Yeah, I was going to say, are you anchoring because of time, or is it because you think the kids are actually ready to anchor after day one?
I think I think there's a little bit of both, but I think it has everything to do with what's my real goal for that group of students, and do they own it enough that anchoring it will. I haven't waited so long that they're all like, duh, we've got that.
Uh-huh.
I'm actually using it as a tool to help them gain clarity, to help them get more clear on their relationships.
Mm-hmm.
In other words, if we anchor, then that means I'm pulling from them. How are you guys thinking about this? And what kind of language are
Yeah.
you using, or could we use to describe the pattern that you're finding? And how could we make some sort of statements and pictures that would represent what you guys are thinking right now? As they put those kinds of relationships and patterns into words, that helps everybody gain more clarity, especially if we bounce back and forth and then we kind of decide what it's going to look like.
Mm-hmm.
That's a moment where, now everybody is more clear, and now we can continue to cinch it, use it in our other work. So
Mm-hmm.
anchoring doesn't mean we're done and we're putting a bow on it. Anchoring
Yeah.
is an opportunity for continual refinement.
Yeah.
And I'll specifically mention high school teachers. This is not trivial. You're kind of like Kim is pushing me to think about, so when do you anchor? One of the things that we tried really hard in our just current high school problem strings workshop, which I'm so thrilled that we've gotten that done and it's out. One of the things that we've done is help you think about what would you anchor after this problem string. In fact, we also help you think about how would you prepare for this problem string, and then what's your goals during the problem string, where the teacher moves as you're facilitating this problem string, and also what are you thinking about after this problem string? And again, high school content, not numbers, not what am I trying to say? Not numerical strategies only, but also, like real high school content, problem strings with graphs and tables and transformations and functions and all the things. Yeah, so it's one of the things that we help you do in our Building Powerful Mathematics workshops, but we also have books with options. In our problem string books, we've got kindergarten through fifth grade problem string books. We give you not only a main string that we write about, every lesson has a main string we write about, and then we give you 2 echo strings that are basically the same relationships that are just another opportunity to do that same thing 2 more times. But then we recognize that you might want to up the ante just enough. And so then we give you what we call next step strings, 2 next step strings. So if there's 48 lessons in one of our grade level problem string books, that's actually 48 times 5, because you have that main string, the 2 echoes, and the 2 next steps. Lots of resources to help you as you are planning problem strings, facilitating them, and then thinking about what am I doing now after this particular problem string.
Yeah, so we just wrapped up the series on planning, choosing a problem string, planning for a problem string, and what you could do afterwards. We hope this has been really helpful. Thank you always for tuning in and spreading the word that math is figure outable.
All right, fantastic conversation about problem strings. Y'all, thank you for tuning in and teaching more and more real math. To find out more about the Math is Figure Outable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figure outable. Thank you for listening and making math more figure outable.
To learn even more about making math figure outable and how to teach it that way, join us for our free challenge starting May 14th.
Y'all, all you need to do is sign up and show up. Register at mathisfigureoutable.com/challenge. We're not punchy today in any way.
That's mathisfigureoutable.com/challenge, and we're looking forward to seeing you there.
Join us at Math is Figure Outable. Bam!